Hello, this is problem number 14 from chapter 7 in the physics textbook. The problem reads, a force 4xi plus 3yj newtons acts on an object as the object moves in the x direction from the origin to x equals 5 meters. Find the work equals force dot displacement done by the force on the object. So the first thing is we see that our force is equal to 4xi plus 3yj newtons. And we're going from 0 to 5 meters, so that will be the limits of our integral. But the weird thing is, what are we going to do about this y? Because we aren't given any information of like, where's the y going? Do we have to do a separate integral? Or what do we have to do? But we can see from the question, it says acts on the object as the object moves in the x direction, so it's not moving at all in the y direction. So even if we were given the, if we were given a separate integral for y, it wouldn't matter because it would just be like an integral from 0 to 0 because we're only moving along the x direction. So in this case, the force in the y direction we can just ignore. So we're only going to be working in the x direction right now because we're only moving in the x direction because that's the only place we have a displacement. So work equals the integral of force dot, and I'm going to use dx because our displacement is only in the x direction, but the book uses dr. So now we know that our limits of integration are from the origin to 5 meters, so we're going to put 0 to 5, and our force is 4x, and then we're going to keep the dx because that will be the variable that we are integrating in regards to. So we're going to do work equals 0 to 5 force dot dx. Work equals 0 to 5 4x dx. So now we have to do the antiderivative here. So what we know is that 4x is like x to the first power. So the antiderivative, since it's a polynomial, would be something to the x squared. So we can just leave x squared right there, and we're going to put the 4 a little on top because we might have to multiply or divide it by something. So if we take the derivative of this, of 4x squared, it would be 8x. So we see that since what we want to have is 4x, we divide it by 2. And another way to think about it is that since we're going up in a power here, you just have to move it around because you multiply it by that 2, so you have to make sure that you don't change the coefficients or anything. And then you go from 0 to 5. Another notation for this, which we learned in class, was just to do 4 over 2x squared and like have a big bar from 0 to 5. But sometimes having the brackets is nice if you have just more than one thing. If you just have like 2x squared plus 7x, it'll just make it easier of holding everything together. So then what we'll do is we can just kind of simplify it to 2x squared 0 to 5. So 2 times 5 squared minus 2 times 0 squared. And these are going to be joules because the force is in newtons and the x is in meters. So that's Newton meters, which is joules. So our work is equal to 50 joules. I hope that answered your question, and if you have any more questions about integration or problem number 14, I'd be happy to help. Thank you very much.